Hey everyone, this is the first tutorial for OpenSees Navigator 2.5. In this module, we will be following the basic truss example from UC Berkeley's site, available in the description below. We will go over basic commands to model this truss and analyze it. To start, we need to set the OpenSees.exe path. So go ahead and click File, Set OpenSees.exe path. Then you have to locate the OpenSees application file. Alright, now we can begin by creating some nodes. Click Edit, Node, and Add. Enter the number of dimensions. In this case, we have 2 dimensions, and we have 3 degrees of freedom. Now enter the corresponding coordinates. All of the dimensions should be in inches. Also note that the input can take operators, which allows for easy conversion. And we click display. Now we see that the nodes are created. Next, we will assign the nodal constraints for the boundary conditions. Go into Assign, Node, Single Point Constraints. For nodes 1, 2, 3, and 4, we must constrain the rotation since we are going to define them as truss elements. Note that we must include a space between the node numbers. And in addition, nodes 1, 2, and 3 must be constrained for any translation. Now we are going to add elements. Click Edit, Element, Add, and insert the connecting nodes. Next, we are going to define the material. Go into Define, Materials, Uniaxial Materials. We select Elastic Material. And we're going to name it Truss Material and input the modulus of elasticity and given in the problem, which is 3000. Then we're going to click Define Elements, Line Elements, and we're going to add a truss element. We can give it the name A1 with the cross-sectional area of 10. And also with the truss material that we just created. You can do the same thing with the other element. We give it the name A2, A3. With cross-sectional area of 5 and truss material. Okay, now we can assign the elements with the corresponding cross-sectional areas. Click Assign, Element, and Types. So element 1 has element type A1 and assign. And elements 2 and 3 have element type A2, A3 and assign. We can now define the load pattern. Click Define Load Pattern. We add a new load pattern. Select Plane from the drop-down menu. We give it the load pattern name Truss Loading and keep the time series as linear default. Now we will assign the load on node 4. We select node 4, truss loading, and fx of 100, and fy of -50. And click Add. You will notice that the loads do not appear, so we need to set the display options by clicking this button. We check the load/displacement box and define the load pattern name. So we choose the load pattern, truss loading, and display. Now the load should appear on the screen in red. By default, OpenSees does not record any analysis if you do not prompt it to. So we need to first define the recorders before analyzing. We go to define recorders, and we need to set one recorder for the truss element and one for the nodes. For the nodes, we select node and we call it node recorder, and we check the displacement box. For the truss element, we select truss and we will name it truss recorder and select global and local resisting force. Next, we will define the new analysis case. Simply go to Analyze, Define Analysis Case, and we give it the name Truss Analysis. Select the truss loading and also the node recorder and truss recorder by using the control key. Finally, input 1 for the load steps. Now you will be prompted to save. Save the file in your desired location. Next, we need to write the input file and run OpenSees. So click this button and we're going to run the truss analysis. And we write the OpenSees file and click the red button to run, and it's okay. Now we need to load the OpenSees results, and we click load. Now to view the results, the toolbar at the top has a few options for the analysis results. Now we will look at the deformed shape of the truss. We go to Animate Response. Select Cubic from the drop-down menu and set it to 10 to see the deformed shape better. Now click Start and you should see the deformation. Note that the bigger the multiplier, the larger the deformed shape appears to be. So if we set it to 15, and we will see a larger deformation. If we set it to a greater value, such as 40, we will see an even bigger deformation. That's the end of this tutorial. Hope this helps you get familiar with OpenSees Navigator 2.5. Thank you.